Hi everyone, I am Ninkalo. Today we will present about the amplitude modulation. After watching this video, you will clearly know the concept of modulation. Firstly, imagine you want to send speech over long distance, but low frequency waves can travel very far by themselves. So we use a carrier wave, which is a high frequency wave, and embed the information into it. This process is called modulation. There are many modulation methods, where amplitude modulation is one of the most basic methods in communication systems. In AM, the amplitude of the carrier signal varies according to the message signal, thereby generating the modulated signal. There are two types of AM signals, which are double sideband full carrier and double sideband suppressed carrier. Next, what is the DSBFC? DSBFC is the standard AM system used in traditional radio broadcasting. It transmits the carrier wave, which is a high frequency signal that carries no information. The upper sideband, which is a copy of the message, shift to a higher frequency. The lower sideband, which is a copy of the message, shift to a lower frequency. Well, DSBSC is similar to the DSBFC, but it removes the carrier and transmits only the sidebands. Next, let's compare these two signals. Firstly, both signals have the same bandwidth, which is 2 FM. The bandwidth is between the upper sideband and lower sideband of the two signals. In addition, DSBSC has better noise performance than DSBFC. It is because DSBFC use envelope detection. Envelope detector cannot distinguish noise variations, while DSBSC use coherent detection. The detection is linear and more accurate. Furthermore, in DSBFC, the transmitted power signal is mostly carrier power signal, contributing 66.67% from the total AM signal, whereas signal content information in the sideband is 33.33%. Hence, the power efficiency is lower. Well, in DSBFC, since it has no carrier signal, all the power transmitted is sideband power. Therefore, the efficiency is 100%.
So, good morning, Doctor. I'm Timber. Today, I will be discussing about recent advancement in amplitude modulations, which is fundamental techniques in analog communication system. So, as shown on this table, my discussion is about advancements in amplitude modulation. For amplitude modulations, I will focus on adaptive digital pulse modulation (ADM) and automatic modulation classifications (MC). These advancements aim to improve signal quality, noise performance, and efficiency, while also providing significant benefit and impact to society. First, I will begin with the advancement in amplitude modulations. Recent developments in amplitude modulation have focused on improving signal quality and transmission efficiency through digital adaptations and intelligent processing. One significant advancement is adaptive digital pulse modulations (ADM). ADM utilizes advanced pulse density modulation (APDMs) combined with nonlinear correlation technique to dynamically adjust the modulation process based on signal conditions. This approach significantly reduces intermodulation distortions (IMD), resulting in cleaner and more reliable signal transmissions. From a societal perspective, ADM enables high-quality digital broadcasting systems such as HD radio and digital radio modules (DLMs) to operate at lower transmission power and operational costs, thereby improving access to reliable radio service, especially in wide and remote coverage areas. Another important advancement in amplitude modulation is automatic modulation classifications (AMC). AMC employs deep learning algorithms to automatically identify modulation schemes in real time without prior knowledge of the signal. This capability allows wireless receivers to dynamically adapt their demodulations and filtering parameters according to the detect modulation type. As a result, communication systems become more robust against noise and interference. In terms of societal impacts, MC significantly enhanced anti-interference performance in ground electromagnetic environments, improving communication reliability for emergency response systems, defense applications, and modern smart communication networks.
Hello everyone, my name is Bavin and now we will have a mini activity to explore amplitude modulation. So, why do we need modulation? It is because in real life communication, low frequency signals like voice cannot travel far efficiently. Modulation allows us to shift the information onto a high frequency carrier so it can be transmitted over long distance. You can try to imagine message signal is a paper and carrier signal is a stone, and you use the message signal as an envelope to envelop the carrier signal, which is stone. So we move to activity 1, which is to explore the time domain signal. The original message signal is on the left hand side. It is a message signal that contains the information, such as your speech or music, while the carrier is a high frequency signal used to carry this information through the channel. You can see on the right hand side, the carrier signal move more frequently if compared to input signal, which is message signal. So this activity will take you to compare between DSP-FC and DSP-SC. Both are the ways to modulate the signal. For DSP-FC, the carrier is transmitted together with the message, so you can clearly see that there are three lines on the left-hand side of the picture. While this makes the signal easy to demodulate, which is why it is commonly used in basic AM radio. The second one is DSP-SC. In DSP-SC, the carrier is removed, so you only left two lines, and only the two lines we call, which is sideband, are transmitted. This improves power efficiency but require more complex receiver for demodulation. Activity 3 is demodulation, which is we need to recover back the original signal. At the receiver, demodulation is used to recover the original message signal from the modulated signal. As shown in both figure DSB-FC and DSB-SC, the demodulated signal closely match the original signal, demonstrating successful transmission and recovery of information. In activity 4, we will talk about noise and signal quality. So basically, noise is an unavoidable part of real-world communication system. In this activity, when 15 dB of noise is added, what will happen? Basically, the output, which is signal to noise ratio, is used to measure signal quality after demodulation. As you can see clearly from the slide above, DSP-FC got negative 2.17 dB, while DSP-SC got 24.83 dB. So the results show that DSP-SC achieved a much higher output SNR signal-to-noise ratio compared to DSP-FC, indicating better resistance to noise. Well, now will be the think activity for you guys. So what do you think will happen if the carrier frequency is too low? I give you guys 5 seconds to think. 5, 4, 3, 2, 1. So now I will review the answer. If the carrier frequency is too low, several problems can occur. First, the low frequency carrier may overlap with other existing signal, causing interference and making it difficult to separate different transmission. While secondly, low frequency carrier are less efficiency for long distance transmission because they cannot propagate as easily as high frequency signal. I believe that everyone got listen to radio when you are driving, right? So I will use radio broadcasting as our example to talk on this activity. So when you turn on a radio, you are actually receiving signal from many radio stations at the same time. For example, maybe you would hear to My FM, 98 or 1 FM. So the original audio signal has a very low frequency and cannot be transmitted efficiently over long distance. By using high frequency carrier signal, the audio information can travel much further and be received clearly by the radio. So this is why modulation is important. It allows low frequency information signal to be shifted to a higher frequency range for practical transmission. The same principle is applied in DSP modulation. where the message signal is combined with a carrier signal to enable efficient and reliable communication.
Hi, my name is Liu Zonghan, and we have seen how AM radio works, but there are still a few misunderstandings about it in terms of safety, health, and the environment. For example, people often think AM radio signals can cause cancer or other health issues because they are radiation, but in fact, it uses non-ionizing radiation at low frequencies, unlike X-rays or UV light. So these waves do not have enough energy to damage your DNA or cells. They are considered safe by WHO for public broadcasting. Other than that, some people believe listening to AM radio near hospitals or on planes is dangerous. But actually, AM broadcast bands are allocated away from critical safety frequencies. So while electronic interference is possible with poorly shielded devices, modern equipment is designed to avoid this. And in airplanes, it's more about avoiding distraction than signal danger. Some people also believe that AM tower could affect ecosystems and environment. But the truth is, while towers must be placed responsibly, AM radio waves themselves do not produce pollution or harmful emissions. The main environmental considerations are land use and visual impact, not electromagnetic harm to nature.